Hey everyone, in this video I will be discussing about merge sort in C++. So basically it will brush up your concepts of recursion. If you're facing some difficulties to solve a problem on recursion, then this video will be very helpful for you. So let's get started with what is merge sort and how we should start learning all those stuffs. And for that reason you have to understand the concept of divide and conquer, how we can basically divide a big problem into smaller chunks and then we solve all those problems and then concluding all those things to get a big result. So let's move to next slide. And first we should understand what is merge sort. So basically merge sort is a divide and conquer algorithm, as I have told you in previous slide. Basically what should be the approach? So the approach is to it divides the input array into halves. So basically what is the approach? So I'm explaining it to you here. So basically you have given an array of, let's say, 4 size. After that your task is to just divide this uh, array into two parts such a way, and this two size of both the arrays has to be divided again. So that's how whole code is working. We have to divide until we get a single element. So that's how the whole thing is working. So this is why all those things has been written, that merge sort is a divide and conquer algorithm, and it divides the input array into halves and sort them. After that, if you basically come here when you have a single element, then you have to do sorting operation. Then you have to sort all those things. Sort means just arranging the array into ascending order. That's how. And after that you have to merge. So how all those things will be working, I will be explaining in this video. And the best and one of the most important thing why you are learning merge sort is that it has time complexity, which is O of n log n. So before that, when you understood all those different types of uh, sorting algorithms like bubble sort, selection sort, insert sort, all these taking O of n square complexity, and this is lesser than that, then this is one of the good thing, as a more efficient as compared to all those things. And you have to also take care that it is taking O of n space. It means that it is taking O of n auxiliary space. It is taking more memory. Why it is taking, I will be explaining when I am coding all those things. So let's get started with another slide. So what is the explanation? Okay, so basically step by step explanation. So first you have to divide. So basically split the array into two half, that I have explained in the previous slide, and just recursively until each sub array has a one element that I have explained to you. I'm just explaining it again so that if you're not getting it that in that slide, then you will be getting in this slide. So basically you have this kind of arrays, and just you have to divide it in such a way that you have just two elements here, because initially you have four elements in the array. And after that your task is to basically divide the array. And because now it is single elements in each array, then if it is a single block, then it is already a sorted array. So you don't need to perform any other type of things for sorting that array, because if you have an element, if in single element, then it is already sorted. So that's how. So this is, I think I am explained. Conquer means just sorting. Just if you are basically going from, if you are coming from this direction and if you're going upward, then you have to sort all those things. How you will be sorting, I will be explaining, and I will be coding in this lecture how all the things will be working. And then you have to just combine. If you are this array, and this whole array will be combined in this, so that's how whole thing will be working. So let's move forward. So basically this is the pseudocode. So let's get started, and I'm writing all those things. So for that reason I'm creating include Ayush stream for taking input output files using namespace std int main. So let's see what is our array. So let's make an array which should be like 6 uh, 4, I think sort of big array which is almost 8 to 9 elements. 9 8 3 and then 5. So this is how I have defined an array of almost size 1 2 3 4 5 6 7 and 8. So the size of the array is equal to 6. Okay, so that's how I have explained. So what should be the starting index of this array? So basically the array is starting from 0th index, and what is the ending index of this array? Why I'm doing all those things? Because when I'm making a merge sort function, then I have to pass all those things. Why I'm passing, I will be explaining. Just wait and just see why I'm doing all those stuffs. And the size of this is array is not 6. I don't think it is 6. 1 2 3 4 5 6 7 8. Okay, so it's not 6, it is 8, and the end will be pointing to 7th. So that's how whole thing is working. So let's make a merge sort function, which is merge shorts sort of. So I'm just passing arr, the starting index and the index and the ending index. If you are passing starting and ending, then you don't need to pass the size, because through that anyone can easily find it out, what will be the size of the array. Just end minus a start plus 1, so that the whole size will be calculated very easily. So you don't need to do all those things. If you want to do, then you might be, but you don't need to do all those stuff. So I'm passing int start as the starting index of the array. So this is your merge sort function. So basically this function will perform in such a way that this array will be sorted. So basically what will be my approach to doing all those stuffs? So basically my approach is like, first I have to divide this array into two equal halves. So the first half should be like this, and just copying it, all those things from here, and now I'm pasting over here and just selecting and just giving into these kind of things. No. So that's how whole thing will be working. I'm just commenting all those stuffs, and after that what your task is to just divide this thing into next slide, next line, sorry, and this from here to here, this has been divided again. Okay, after that these thing has also be divided, and after that this is also. Okay, I'm just copying all those stuffs from. And then after you have to do the same thing. Okay, so basically what I have done, I'm explaining to you. So this was the array that I have given to you. Then you have divided this array into two equal halves. So you have divided in this way, that's 6 4 7 and then 2, and after that this 9 8 3 and then 5. So that's how this is divided. After that this array will also be divided into two equal parts. So how it is? So this is 6 and 4, this 7 and 2, and this is 9, 8 and 3, 5. After that, this array will be divided again as 6, 4, 7, 2, 9, 8, 3, 5. Okay, so after that you can't divide because a single element can't be what should I say, can't be uh, divided again. Okay, so after that, what will be our approach? Then if we have a single element in an array, then this array will be sorted, because any single element in an any array, in an array, which is always sorted. So then I have to just backtrack all those stuffs and just go to next step, and just this and this will be sorted. So how it will be sorted? That 4 and 6. So 4 will be now at this point, and then 6. How? It will be done by recursion, so you don't need to worry about how it is working. Recursion will do all those steps for you. Okay, then 8 and then 9. After that, 3, 5 is already being sorted, and after that you have this and this. Then you have to just sort all those stuffs to, then 4, then 6, then 7. After that 3, then 5, then 8, then 9. Okay, and after that this and this will be merged, and the final output will be 2, 3, 4, 6, 7, 8, 9. So that's how the process of merge sort will be working. So I think I'm able to explain to you how I have sorted all those stuff. Then I have to just write the code how all those things will be working. So for using recursion, you have to just understand the base case. So what should be the base case? Base case is very simple. When a start is greater than equal to end, it means that the start is extending to the end, which is you always being using while solving problems of two pointer approach. So every two pointer approach was doing all this, and then your task is to just return, because you're using void functions. So that's how all things is working. So let's move, and basically how we should divide an array. So for that, I have to call this merge sort function for dividing. So if you want to dividing merge sort, then you have to pass the array, and from where to where you want to divide. So let's say this is the whole array, and if I want to divide this array into two equal chunks, then if I want to give some name about this array, let's say this is the left array and this is your right array. So for that reason, I'm dividing for left side, left part. So initially the start should be pointing to uh, this, and the end should be pointing to the mid. So for that reason, first I have to basically create what will be the mid. So mid, as always, you always know that if you want to use this start plus end minus start divided by 2 for avoiding the overflow condition. So, and initially your start should be pointing to this start, and then end should be pointing to mid. Okay, so it will divide from taking start here, which was initially at 0, and mid was here. Why? So if you want to know why I'm using this mid over this end, because I want to basically divide this array. So how I'm dividing it? So initially our start was pointing to this 2, and the 2 is on 0th index. So 0, 1, 2, 3, 4, 5, 6. So 6 by 2, which will be equal to 3. So mid should be pointing to the third index. So 0, 1, 2, 3. So that's how it was divided. So I think 1, 2, 3, 4. I think I have done something wrong here. So I think this will not be the answer. So initially 2, 3, then 4, then 5, then 6, then 7, then 8, and then 9. So that's how, yeah, it's totally fine. So so initially start is pointing to 2 and end is pointing to this. So for that I have calculated mid. So mid was pointing to this 1 0 0 1 2 3 4 5 6 and 7. 7 by 2, which will go to 3, point to the third index, 0 1 2 and 3. So this is how things will be divided. So so if you want to divide from here to here, then your indexes of start should be start should be pointing to this and end should be pointing to mid. And after that, this 6 to 9, you have to start from this and end with 9. So how you will be doing? For right side, right part or right side, anything, merge short, and you have to pass the array. And if the start, if the mid is pointing to uh, third index and you have to divide from here to here, then mid will be pointing to mid plus 1. So 5 was it 5, the 5 number of third index is the mid. Then if you want to divide from the next number, then mid should be what equals to, it will be equals to mid plus 1, and end should be always be equal to the end, so you don't need to worry about that end. So mid plus 1, then so this is the code for basically uh, dividing the array. So you have divided the left part and the right part also, and then you have to sort. No, you don't need to sort it, you have to just merge it. So how will you merge? You should use a merge function for that. You have to pass array, the start, the mid, or the end. So I'm making it a void function. Okay. Okay, and end. So this is the merge function. We'll be merging how these things will be merged. So let's see. Uh, I have told in previous slide that it will be taking an space complexity of O of n. Why? So I'm writing for that. I'm creating a new array or new vector for that, for storing some answers. So vector of type int, and the name should be equals to temp, and the size of the temp should be end minus start plus 1. Why? This is a good question. I will explain. Because if you want to know the size of the array, then if you have the nth index, which was initially 0 1 2 3 4 5 6 and 7, 7 minus 0, which will 7, plus 1, which will be equal to 8. So this is the size of this temp. So the temp vector will be of same size of this array. Okay, I think I am able to explain to you. So just I'm storing all the answers in temp variable, so that temp vector, so that this initial array will not be lost. So that's how I'm using this thing, temp variable. So let's move forward, and for that reason I'm creating some variables like left, which will be pointing to start of the index, and the right will be pointing to mid plus 1. How mid plus 1? As I have explained in this, how all those things will be working. And the index of this temp will be basically initialized with what? 0, as we all know. This is how I have explained. So basically this left will be pointing to this element, this starting, this right will be pointing to this mid plus 1th element, and I have created an empty array like that, and this array of size same 8. Initially if you create all those stuff, then all the element will be equals to 0, or it may be basically storing some garbage values. So it is initially an empty array, so I have to do all the things in that empty array. So let's move forward. So while left should be less than equal to mid, and right should be less than equal to end. So this is the condition where this left will not be going beyond mid and right will not go beyond end. So that's quite correct. So how it is correct? So I will be explaining. So left, this left, and this is the mid. So 2 is 2 is the left array. Sorry, 2 is starting with this start and ending with this mid. So if the left moving from after the mid, then I have to stop this loop. So just I have to compare this 2 with this 3, and if I found this is the shorter, then I have to store that thing and just moving the left pointer, and else we have to move the right pointer. So I think I'm able to explain what I have said to you. So if ARR of left is less than ARR of right, then your task is to just temp index is equal to ARR of left. So that's how whole thing is working, and I have to just increment the index as well as left, and else temp index is equal to ARR of right and index plus plus as well as right plus plus. So basically what the whole thing is written. So I'm try running all those stuffs. Initially left was pointing to 2 and right was pointing to this 3. So I'm comparing both the things, so which one is shorter. So if 2 is shorter than 3, as it is correct quite, then I have to push 2 in the this vector temp and just increasing the index of the temp, which was initially at 0th to 1, and then this left pointer is pointing to the next element, and then this whole thing is working like 4 is compared to 3 and so on. So that's how this code has been written out. So is it completed? No. So there's a chance that if an array is already sorted array, so the left will be basically at this this kind of things can happen, like wait, I'm writing, then you will be getting what I'm saying. So there is another thing that can be happen, like left is just this kind of things, then you have to just do same thing. And if right just have to copy all those stuffs and just paste it. So basically what from line number 18 to 25 is doing all those things. So let me explain. So basically if the array is already sorted, then what you have to do, just copying the already pre-built sorted array. So how so basically uh, we know that this array is already sorted, this array is also already sorted. So in some cases, then this, what, the left is now pointing to this, uh, after this 6, then you have to just copying all those stuffs and just paste it over. So that's how I am writing all those things. So basically now the temp array has all sorted things. So just I have to uh, copying all those temp variables and copy all those things into this arr. So how, so now the index will point into the zeroth, and while start is less than equal to end, I'm just copying the arr of temp, arr of start, sorry, is equal to temp of index, and just start plus plus and index plus plus. So that's how whole thing is working. I will write on all those stuffs first. Let's execute it. Is it working or not? Print array. Okay, which is not working. So that's, what is the size? 8, 6, 4 and 4, 8. Okay. Okay, okay. 2, 3, 4, 5, 6, 7, 8, and then 0. How 0? Okay, so let me check. I've done something wrong. So is it starting with 0, 0, 1, 2, 3, 4, 5, 6, 7. Perfect. So I think, let's say the size, if you execute from this, then yeah, it is perfectly fine. So let's conclude all those stuff that I have explained to you. So basically, this is the base condition for this merge sort function. If start is greater than the end, then you have to return from that. First you have to calculate the mid is equal to start plus end minus start divided by 2 for avoiding this uh, overflow, integer overflow condition. Merge sort, if you are basically dividing the array into two equal halves, the left part is now merge sort and arr start and mid, and another thing is right part, which is arr mid plus 1 to end, and then you have to merge the whole thing. So arr start, mid, and then end. Now this is the code for writing the merge. So here we are merging all those stuffs. So I'm creating a auxiliary space for that reason of temp name of this vector, and the size of the vector is end minus start plus 1. Okay, so initially the left pointer is pointing to the start and the right pointer is pointing to the mid plus 1. After that, the index of this temp variable is now initialized with 0, and after that you are performing something like that, like if you write this thing, I think, yeah, it would be more fine. Yes. Less than equal to condition, I'm using this. Okay, then you have to just copying this error of left into the temp and just increasing both the things. If you really like that you're not getting it, you just dry run on your notebook. You will be easily getting what I have written on. If anything in my this code you are not clear with that, you just dry run how it is working. Just take an example by yourself and just dry run all those stuffs. You'll be easily finding how things will be working. Okay, and why all those things has been written like left is less than equal to the mid, then you have to just copying all those stuffs into the temp variable, and same reason for right. If you're not getting it, just go and dry run. You will be easily getting all those stuffs. So this is how all the things is working. So let's move forward and see something. So basically this is the pseudocode. I have explained it to you, so I don't think, and this is the example that it has been taken over, that first they have created this half array and the right half array, and just after that merge this kind of thing. So how it is merging, writing, pointing, start pointer, left pointer, and this is your right pointer, and just comparing all those stuffs. If one is if 2 is less than 1, is it true? No, it is not. True is greater than 1. So right pointer will be shifted to now here, and 1 will be placed here, and then compare 1 and then 5. So basically how things will be working, let's execute all those stuffs. Okay, so initially our left is pointing to here and the right is pointing to here. First comparison will be happening, then comparison between 2 and 1. So as we know, 1 is smaller than 1 will be initially pointing here, and the pointer of 1 will be in move to this. Then 3 and 2 will be compared, so we know 2 is lesser than 3, so the 2 will be on this merged array, and the pointer will be now pointing to the next member, and then 3 and 5 will be compared. Then 3 will, as we know, all know, 3 is lesser than 5, then 3 will be at this point, and then we have to move this 3 pointer to next pointer, and just comparing 5 and 7. Then as we all know, 5 is lesser than things 7, then this is pointing here, and now pointing to here. So comparing 7 and 8, and 7 is shorter, so that's how. And then this will be pointing to this. So if this pointer is beyond this size, this mid element, or the in right part the nth element, and in left part mid plus 1 or after mid, then you have to just copying this same thing and just paste it over. So that's how these things will be working this. So let's move forward and see some more thing. This is the code that I have explained to you. So why it is basically used, or reason why we are learning all those stuff. So basically this is efficient for large data set. If you are using basically very big data sets for searching something, and as I have explained to you, that its complexity is n log n, which is the best, and a stable sort maintain relative order of equal elements. So as I have explained to you, so these are the key takeaways from this lecture. So what it is: merge sort uses divide and conquer, suitable for linked list and large data arrays. I have explained, and understand its implementation for interviews and practical uses. And call to action is that try implementing merge sort in your project. So if you want to really do something in merge sort, then you have to build some project like that. So guys, thank you for watching this video. If you really like this video that I have explained it to you, then please like, comment and subscribe. Thanks.